Lesson 103, powers of negative numbers, dividing terms and square roots of monomials. So when we are multiplying a negative times a negative number times a negative number will give us what kind of number? Positive. What if I had a negative times a negative and then I timesed it by another negative? What would I have? A negative, because these two are positive. What about a negative times a negative and then times another negative? Positive. How about all of that, negative times a negative, times a negative times a negative, and then one more negative? Negative. Notice that when we have an even number of negatives, the answer is positive. When we have an odd number of negatives, the answer is negative. So we're going to write down what we have discovered. If you have an even number of negatives, make it negative factors. The product will be positive. So an even number will be positive. If you have an odd number of negative factors, the product will be negative. So here's a couple of examples. If we have a negative 3 times a negative 4, there's an even number of negatives. So the answer will be positive. So it's going to be 12. Here's another example. We have a 5 times a negative 2 times a negative 3 times a negative 4. So if we just multiply 5 times 2 times 3 times 4, we get, 12 times 10, 120. But since we have an odd number of negatives, it's going to be negative. These two don't equal. So we think of just multiplying the number parts and counting up if they're odd or even to know if our answer is negative or positive. When we divide terms, we cancel out what is the same in the numerator and the denominator. And you guys have divided before and canceled, so it should kind of sound familiar. And we've even canceled labels. Like if the label is the same, we can cancel it. So we just cancel out what is the same in the numerator and the denominator. So here's an example. If we had 3x cubed y squared divided by 6x squared y squared. We can think of it as 3 times x times x times x times y divided by 6 times x times x times y times y. Then we can cancel what's the same. Or if it has the same factor, like 3 and 6, we can divide both of those by 3. 3 will go to a 1 and 6 will go to a 2. Then we have an x in the numerator and denominator that we can cancel, and I have to cancel x just straight up and down, because if I go sideways it just looks like I'm crossing my x. Same with this one. Then we can cancel 2 y's, and we look at what's left. We have 1 times 1 times 1 times x and all that, so it's just x. And here we have 2, just 2. All of these went to 1s. We're times it. When we look for perfect squares, do you remember when we talked about perfect squares and we listed all of them? Like 1, 4, 9, 16, 25, 36, 49. We look for a perfect square number, and then we look for even exponents on our variables. So here's an example of a question you might see. Is this monomial a perfect square? And this is one we're looking at. 100x squared y squared. So if we were to write out the factors, 100 is 2 times 2 times 5 times 5. X squared is x times x. Y squared is y times y. If we have groups of 2 of every factor, then it is a perfect square. 2 2s, 2 5s, 2 x's, 2 y's. Since we have groups of 2, then yes, this is a perfect square. So if we were asked to find the square root of this, since it's a perfect square, we can find the square root of each one of those. So if we had the square root of 100 times x squared times y squared, we would take one factor out of each of these pairs and multiply them together. So this is a pair of 2's, a pair of 5's, a pair of x's, and a pair of y's. So it's going to equal 10xy. That's the square root of 100x squared y squared. And I have one more sentence before we do our lesson practice. So that means I have to turn the page. For a monomial to be a perfect square, the exponents on all the variables must be even. That way we can get groups of 2 out of there, so we can take the square root. Okay, that's the end of the lesson.